Oh, this is Scholar Strife doing some math today in geometry where it proves statements about segments and angles. So, we learned about these reflexive, symmetric, and transitive properties. They also work for segments. So, AB, the segment AB is congruent to the segment AB. That's a reflexive property. I am myself. Symmetric says if AB is congruent to CD, then we can reverse them. CD is congruent to AB. And then the transitive, if AB is congruent to CD, and CD is congruent to EF, then we can go straight ahead and say AB is congruent to EF. And same thing with angles. Angle A is congruent to angle A. If angle A is congruent to angle B, then angle A is congruent to angle B. Or reverse. Angle B is congruent to angle A. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Alright, let's go to the statements and reasons. Okay, so this is how some of your homework problems will look. They'll say given, blah 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 blah, and they'll give you a picture usually, and then they'll say prove angle 1 is angle 4. So what we always do is with our first statement, so I'm going to say statement 1, measure of angle 2 is equal to measure of angle 3, and then measure of angle AXC is equal to the measure of angle AXD. Okay? And that was given. So angle 2 is equal to angle 3, and they tell us that AXC, so angle AXC, that's angle 3 plus angle 4. And then angle AXD, that is, from our picture, angle 2 plus angle 1. Okay? So our goal is to get measure of angle 1 equaling measure of angle 4. So all the way down here, don't know what step it is, we're going to have measure of angle 1 equal to measure of angle 4. So when we're doing these proofs, normally it kind of follows from one of these given facts. So, for example, angle AXC is equal to angle 3 plus angle 4. So that naturally was followed by just looking at the picture, and that's called our angle addition postulate. And then same thing with angle AXD. That was angle 2 plus angle 1. So angle addition postulate. Okay. 4. So now that I'm looking at my statements, so I see it. So angle 1 has appeared. So, but it has angle 2, and then angle 3 plus angle 4 has also appeared. But notice in the statement 1, AXC is equal to AXD. If they're equal, I can set statements 2 and 3 equal to each other. So angle 3 plus angle 4 is equal to angle 2 plus angle 1. That's through substitution. Okay. And then 5. I'm going to do substitution again, because in our first statement, angle 2 is equal to angle 3. So I'm going to say, so I'm going to replace one of these. I'm going to say, instead of angle 3 here, I'm going to say angle 2, because it's the same. So angle 2 plus angle 4 is the same as angle 2 plus angle 1. And that was another substitution. And then lastly, I can subtract angle 2 from both sides. Subtraction property of equality. Because they're on both sides of the equation, I can subtract them. And I'm left with angle 1 is equal to angle 4. Now once again, it just takes some practice trying to get through these. There's different ways of solving these, but it normally starts out with your given, and then using your given to give you something else. It's like, for example, AXC is equal to AXD. Well, what is AXC? So we put out, what is AXC? AXC is angle 3 plus angle 4. AXD is angle 2 plus angle 1. Since they're equal to each other, we can set angle 3 plus angle 4 equal to angle 2 plus angle 1. So it takes some experience. Like I said, you're not going to master this right away. You might not even master it at the end of the semester or at the end of the year. But we're introducing you to this idea. But you do need to try. You can't just... It's not going to go away. This is the main thing of geometry, is this whole logical proof thing. Alright, let's do another example. So they tell you that BC equals AB. Prove that AC is AB plus AB. So this one is a lot shorter. So statement, reason. And then I'm going to shorthand this, SR. And you may do this after a while, but just know what they mean. One means statement, one means reason. So always start off with your given. Our given is BC equals AB. Okay, that's given. 2. Well, we want to prove AC equals AB plus AB. So what is AC? AC equals AB plus BC. And that was segment addition. We're allowed to add 2 pieces together to get a big piece. Okay. Then, now we always look back on our first statement and see if we can use it somehow. BC equals AB. I can use the substitution property. I'll replace BC with another AB. AC equals AB plus AB. That was through substitution, and look, we're done. Let's move on to the next one. So BD bisects angle ABC. Okay? Prove that the angle ABC is 2 times the measure of angle 1. Okay? So statement, reason 1. BD bisects angle ABC. And we always say given because it was given to us. Okay? So, what does it mean to bisect? It means that the measure of angle 1 is equal to the measure of angle 2. So we need to write out the definition of bisect. So if a ray bisects an angle, then it divides it into 2 equal angles. Okay? Because that's the definition of bisect. And no, you can't just write definition of bisecting an angle. You got to write it all out. If a ray bisects an angle, then it divides it into 2 equal parts. So we have angle 1 equals measure of angle 2. Next, we need to find out. We need to establish what angle ABC is. Measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. And that's through angle addition postulate. So only postulates you can shorthand, or the properties of equality, the algebra stuff. Okay. So for measure of angle ABC is equal to 2 times the measure of angle 1. 2 times the measure of angle 1. And what I did there is I substituted measure angle 2 for measure angle 1. Because we know that measure of angle 1 is equal to measure of angle 2. Therefore, this measure of angle 2 I can change into measure of angle 1. Because they're the same. Alright, name the property illustrated by these statements. If Q is congruent to V and V is congruent to T, then Q is congruent to T. So this is the transitive property. If A leads to B and B leads to C, then A leads to C. I am myself. Remember, that's reflexive. And then lastly, we can swap each other around if we're symmetric. So concept, writing a 2-column proof, proof the symmetric property. So always start out with what you're given. Okay, statements based on facts that you know. So the segment of AB is congruent to CD, therefore their lengths are equal to each other. And we can swap them around if we want to using the symmetric property. Okay. This is a little bit redundant, the whole... I mean, you could have went from... This could have been done in 2 steps. Because they're saying AB is congruent to CD, prove that CD is congruent to AB. Well, by the symmetric property, you just swap them around, you know. But anyways... that's all for today. Once again, you're not masters of proof, or maybe you are. That's great if you are. If you're not, You still got some time to go. Lots of time. Have a good day.